correct. So, and now D. Let's move on to that one. Whoops, D goes under actually. So let's put D here. Since we did offset this a little bit. Let me zoom out a little bit. So P, Q, Christ. Okay, sorry. I'll have to write this in a smaller fashion. So we were here. Okay. Let's zoom this back in. So in keeping with this tradition, the tree for this one would probably best be made in the other sheet. So let's take this one over to the other page. And let's see. So first we select the middle. We could follow the traditional formula, right? But here's where strategy can come in. Let me, this one is bothering me a little bit. If we pick this one, which is on the upper level of the expression. Oh, and in any case it will have to be picked because this is between the biggest parentheses out here, it seems. So we have to pick this one either way. But yeah, okay, let's do that then. So we have the implication of another implication between Q and P. Then we have this implication between the nullification of the implication. Hold on. So this translates to this. This translates to this. Correct. So yeah. Let's see. Very, very finicky approach, but we can do it like this. And it's a good demonstration as well for how not to do things. So R and S. Then we pick out this side, and the uppermost operator is this implication. So we get this implication between here's something curious we can do. Because this is a tree, right? We can simply weasel ourselves more space. So here we have, let me reiterate what's up there so you don't lose track of it. Using strategy here. So negation of Q, ran out of space. Implication of negation of S, and then we close this and close that. So this negation right here, we're gonna use this negation from here. Let me just recheck. So that one, this one, and then that one corresponds to this one. Yeah, we're good. Okay, so and that one corresponds to that one, so we're good. Now let's see. Let's begin with the leftmost part. We got a conjunction between P and R. And on the other side, we have a conjunction here between the negation of both Q and R and S. That's what we have. Okay, so that's that. Next up, we have the following propositional variables: P1, P2, etc. until P20. So we have in total 20 propositional variables. And let's say that from the exercise, let's say that V is a valoration. So V, we have this definition. V of any of those propositional variables. Can I write this better? Let me try it. Yeah, so V index I means any valoration. So a valoration in regards to P and I is substituted by any of those. So it can be any of those, meaning it can be all of them, meaning it's all of them. So it represents all the events that that encompass these these variables. So for each of them, so for each of these propositional variables, we can have the values 1 and 0. And there is a condition for the value 1, which is that I must divide 3. So this is mathematical. So this is a condition, correct? So if and only, or I'll just say if I divides 3. So this is the condition. This is the division symbol, means that whichever this term is, it must divide 3. So sorry, I had to respond to a colleague of mine. So what does this mean? It means that I, whichever I is, so out here in this subset, or should I say one of the subsets, which will be comprised of the I, which divides 3. So, or in other words, we will grab the p's and the p's which have an I equal to a divisor of 3. We'll grab that variable and assign them the value of 1. Now the only dividers for 3 are 1 and 3. So you can't divide 3 by, well, in integer division, 3 is only divisible by, this is the same as saying that 3 is only divisible by itself, and 3 is divisible by 1. If you use 3 divided by 0, it's impossible. If you use divided by 2, it's not an integer division, it becomes decimal. 3 divided by 2 is 1.5. This is a decimal number. So, and the condition for 0 is anything else, so otherwise. Alright, sorry for taking so long with this one. I was half distracted. Okay, so our job is to find the value or the valuation for phi given the following formulas. A is the formula phi given by P3 intersection with P2 or P3. Then I'll keep that open actually. So B, then we have B, which is phi defined by the negation of P index 20, which implies P3, which implies the negation of P20. And then we have C, which is phi, where P2 implies the negation of P3 in conjunction with P2, which itself is in conjunction with P3. Let's keep going. Then we have D. Let me separate this a bit. D, in which we have 5, where we got P1, disjunction, P3, conjunction, P2, P3, negation P3. Right, so how do we solve this? It's pretty simple.